So now I'd like to go over practice examples from the book. So now I'd like to go over practice problems from the book. So 8.1 is write a function called display message that prints out one sentence telling everyone what you are learning about in this chapter. Call the function and make sure the message displays correctly. Sounds easy enough, right? So now what we're going to do is we're going to start a new file. We're going to save as in class, and then we're going to do message dot message2.py messages.py. Save that. And now I need to go to open the folder. Okay, so there's my messages. So now display message def display message, and then it needs to message, and then so all I'm doing here is defining the function print message. Here's my document string or doc string, print all functions should have a main function. So, sorry, all functions should have a doc string. So now I can call the function this way: display message, and then I am learning about functions. So now if we ran this code, start with that debugging. So there I'm learning Python code. So the problem with this is this function call is going to always be called if I import this module into another module. And so I wouldn't want that to happen. So here I can define my main function, def main, and then call the display message from my main method that will call all of my stored procedures and then run that. And now I have to call main to execute that. And this is where we test if the module is being imported or if it's being run from that module. So if name equals main, and we need to call main. And so now we run this. Sweet, done. And so here, if we do print main. Sorry, it should be name. We see that it's equal to main. And this will become important when we create another module that we're going to import this module into. So now we're going to go to a different problem. Yes. So now we're going to, using a program you wrote that has one function in it, store that function in a separate file, import the function into your main program file, and call the function using each of these approaches. Okay, so now we're going to go through that. So new file, save as, and this will be called import example .py. So import messages. So if the module is in the same folder, Python will automatically find the module. If it's not in the same folder, you can add it to the Python in variable, so that you can Python will know where to look for the modules. The other place you can store it is under libraries within the Python binary. So there's ways to store Python modules not in the same folder. The easiest way to do that is to store them in the same folder, because then you don't have to worry about it. So I'm importing message, and then I need to have a def main function, and then messages, and then I love Python. Now if I run this, what will happen? Well, nothing will happen because I haven't called main yet. So now we need to test if name equal main. I want to call the main function. Now this is where we're going to come back to and show this. So print name, which is an attribute of the module, and then I want to print messages dot name. So if we run this, we're going to see the difference and why we need if name equals main. Start with debugging. Sorry. If we run this. So I needed to add, so if you import the module, you need to call messages and then the function call. So we see that main is being called from this module, and display messages is being called from messages. So this allows us to know if a function is being imported and or not. And so this is helpful to write your code so that not all code gets executed if you import a module. For instance, if you didn't have this and you imported the math library, then you could have all of the functions run, which is not something you'd want. So now getting back to this problem, I need to run through the examples. So there's multiple ways to import a module. So import module name, I already have. You can also do from messages import display message, and then all you don't have to declare the module because you've already declared it here. So now if we run this, start with debugging, that's just because of the print statement. If I remove this, it will work. And we see I love Python. And then if you wanted to do from as ds or dm, start with debugging. So we see we can do that as well. And then we could do import module name, import module name as ms. And so then it would be ms.display message. And if we run this, we'll see that it works as well. Sorry, as. So we see again that works. And there's one final way that is actually discouraged from message is import star. And the reason this is discouraged is because it's importing all the functions, and you can have name collisions, namespace collisions. So it's frowned upon. Also, you're importing all functions. So if you have the math library, that's not the best way to do it. So for instance, why is importing star bad? So namespace collision, it may be inefficient if the module is large. It doesn't explicitly document the origin of the variable method class. So if you do use import star, it's hard to know where the function came from, especially if you have multiple import statements. So having said that, this is not the best method to import your functions. I tend to just do import the module, or sometimes if I'm not using a lot of the modules or functions in the module, I'll just import specific functions within that module. So it depends, but I almost never do this. This is bad form because of namespace collisions, and it's writing everything to the namespace, which is why you can have namespace collisions, which is why it's frowned upon. So now that we've covered this problem set, I'd like to move on briefly to the other other practice problems. I'm going to stop recording and then continue. So 8.12, write a function that accepts a list of items a person wants on a sandwich. The function should have one parameter that collects as many items as the function call provides, and it should print a summary of the sandwiches that is being ordered. Call the function 3 different times using different numbers of arguments. So first of all, how would you think about solving this problem? The first thing I thought about was args and quargs to solve this problem so that we can have unlimited parameters based off of position. So if we did so sandwich is def sand So now we have our sandwich function. Now we're going to call it 3 times. So I've defined, so here's my argument, here's my parameters. So I have arguments. I iterate over the arguments. I print I, sandwiches function, which prints the sandwiches. Now I'm calling my sandwiches function, and I passed in as arguments turkey, BLT, PBJ, and I could call this 3 different times with 3 different lists of three different arguments. So now if I run this, start without debugging, we see that it's printing correctly, and I'm using args here to achieve this goal. So that solves that problem. So the next problem is 8.9. Make a list of magicians' names, pass the list to a function called show magicians, which prints the name of each magician in the list. Sounds relatively easy, right? So now what we're going to do is, so I have a magician's def show magicians list magicians for I in list magicians, print I. So now I'm going to print them, and I need to pass in show magicians Luke. Start with debugging. Oh, sorry. This should be a list. There we go. So I passed in the wrong arguments, which is why it was printing Luke down long before. So now we see show magicians. I've passed in multiple names. I've iterated it. And now we're going to move on to the next problem. So now, unchanged magician. Start with your work from exercise 810. Call the function make great with a copy of the list of magician names. Because the original list will be unchanged, return the new list and store it in a separate list. Call show magicians with each list to show that you have one list of the original names and one list of the great added to each magician's name. Okay. So there's two ways to solve this. The first way I solved it is the easiest way, I think. So make, it technically doesn't solve it the way that it asks to, but this is an easy way to solve it. Make great. And then we're going to pass in the magicians. And then return So this is the first way you could solve it. Start with debugging. And then the great. Technically, that doesn't actually solve the problem the way they wanted it, because they wanted a copy of the list and then a new list. So to do that, what we'd have to do is print I, and then we can return the list of magicians. And then I would do it this way then. So if this is the way they want it and they want two lists, I would do it like this. So show list is here in make great, and then sorry. So now I'm going to have an empty list. And now I'm going to want to do I plus the great So now I've iterated over it. I've appended to the new list. I've added the great to it. I print it and then return it. So then all I'd have to do is just call make great and then also another comment, your main function should always go at the end of your module right before, so your main function should be down low here because Python reads from top to bottom. So typically I have my main function below. I'm doing some cleanup on the code. So there, now we run this. So I misspelled return, so I need to do return. And now run this, start. Here I forgot my parentheses. This is Python 3, so that's a function call. So I've passed in the original list into make great, and now I can add it. You do have to iterate over it twice, but you're technically making a copy and doing what the homework says. So Luke the Great, John the Great. Technically, if I wanted to do, I could also. I'm not sure. I had internet connectivity issues, so I can walk back briefly what I did. So I have show magicians, which prints the magicians and then returns the original list. And then I have make great. I pass in magicians. I create a new list. I iterate over the list. I append the great to each item in the list. I print it, which technically isn't required here, and then I return it. And here's where I call the magician. So I show magicians and then make great. So I have my two function calls here, and then I pass in magicians, which is the return list, which is the original list. And then my copy is the output of make great. So that's how you can keep a copy and then make changes and then return the updated copy or the new copy. So the next problem is called albums, 8.7. Write a function called make albums that builds a dictionary describing a music album. The function should take in an artist name and album title, and it should return a dictionary containing these two pieces of information. Use the function to make 3 dictionaries representing different albums. Print each return value to show that the dictionaries are storing the album information correctly. Add an optional parameter to make albums that allows you to store the number of tracks on an album. If the calling line includes a value for the number of tracks, add that value to the albums dictionary. Make at least one new function call that includes the number of tracks on the album. So sounds somewhat similar to using dictionaries, which we've already covered. So let's try to do this. We see that our main function is below. So we'll add another function here, def make album. name, comma, album title, comma, track equals default value of none. We'll come back to why I need a default value later. So now we're going to do our docstring. Add name and album to dictionary. So create an empty dictionary. So I'm going to use the dictionary key would be name, and then use name, which I'm passing in. And then title. So that will be the key, and then album title. And then if track is not none, so this is allowing for optional parameters, int. So a track has to be an integer. So I want to make sure that it's actually an int. So I have my optional parameter. I want to make sure that the track is actually an integer. So I can do that using a new function that I'm going to write. So I'm passing in two parameters, and now I'm going to write my own function. So def value type, and then value, comma, value type. And now use is instance to ensure the value is of type value type. So if is instance value, comma, value type, return value, else raise exception value must be dot format, and it should be value type. There we go. So now I have my error handling, and then I return the dictionary, and I would have to call it as well, which would be, so now I can call it in my main function here down below, which would be right here. And I can comment this out. I think it's control. And now if I run this, start without debugging. Sorry, I misspelled this instance. Sorry. So we see that it prints Bob Dylan Hurricane. We see that it prints U2, and then we see it prints an error because value must be class int, and I have it as a string. So I'm error handling the correct data type for track because it has to be an int. So you can use isInstance. You can also use a try except block, but for integer, for testing if it is actually an integer, you want to use isInstance. If you wanted to test if it could be converted to an integer, you could do try except. So it depends what you're trying to do. And we can go over that later. So as I was saying, the try except. So terminal, I should be able to do this in terminal, Python. Actually, I don't want to do this in terminal. So I'm using isInstance to test the data type. Another way you could do this, and it's actually would be the wrong implementation for this example, but is powerful. Let's say I have somebody types in $10 for price. Well, a price can be a float. So what you'd want to then test is, can I convert that input into a float? And if you can, then it's valid. If you can't, then it has an error. So try so now I'm trying to typecast it, except so this would be a value error because it's the wrong type. So now if we run this code, and comment this out because of the error. We see that it's possible. But now if I did this, we see foo can't be converted to a float. So that can be a useful way to make sure that the value is numeric. This tests the data type. So depending on how you want to test, there's different ways to test. You can either test the data type or the actual, if you can convert it to the right data type. I look forward to seeing everyone on Thursday night.